Okay, this is the last section for this day. This is 10.3. This is compound interest. So it's a little different. The formula is a little different as opposed to simple interest. So compound interest is computed on the principal, and any accumulated interest is called compound interest. So it can be compounded at a different rate. So this is the formula. P stands for the principal. That's how much you're borrowing. And it's 1 plus, this is the rate written as a decimal. This is how many times it's compounded. That's what changing it. The compounding goes up here, and then times the time in years. So notice this is, N is per year, and T is in years. So you have to make sure they're in the same, and it's an annual interest rate. So here's a question. Kathy invested $3,000 in a savings account with an interest rate of 1.8% compounded monthly. So that's what you're always looking for when it says that. Kathy makes no other deposits in this account. They always say that. So that makes it an easy, that you can use this formula, determine the amount in the savings account after 2 years. So she has $3,000. So it's 1 plus this 1.8 written as a decimal, so you move it 2 places to the left, it would be 0.018. Now, because it said monthly, how many months are in a year? 12. So now the 12 comes up here, and so does the 2. You have to make sure if you're doing this in your calculator that you multiply these numbers before you use them as an exponent. So the way I would do that in my calculator is this. I would put in 1 plus 0.018 divided by 12, gets what's in the parentheses, raised to the, I have to go to my calculator for that, 12 times 2 is 24. Now, when I'm all done, I'm going to take that number and multiply it by 3,000. I saved that number for the end. So there's my answer. My answer is 31.09 and 88 cents. Okay, so the 2 went here for the 2 years. This 12 is here and here, but you have to make sure you multiply those. If you just put 2 to the 12 times 2, what the calculator, depending on your calculator, it'll raise it to the 12 and then take that answer and multiply it by 2. You have to be careful with your calculator. Okay, so here's another one. Again, $3,000, 4% compounded. Now it's semi-annually for 7 years. So I'm going to take $3,000, 1 plus, I take this number, change it to a decimal, which would be 0.04, and I put it over this number. Semi-annually happens twice a year. Monthly was 12 times, semi-annually was 2. So then this 2 comes up here again, and it's times 7 years. So this is a 14. So in my calculator, again, I do 1 plus 0.04 divided by 12. Get that in. Oh, I did 12. 1 plus 0.04. That was the last question. Divided by 2. There we go. Raised to the, so that's what's in the parentheses, raised to the 14. Then at the very end, I multiply by 3,000. So how much she's going to pay is $3,958 and 44 cents. Notice the question it said calculate the interest. So if I subtract off the 3,000, here's the interest right here, 958.44. So make sure you answer the question. Okay, so that was the interest. Okay, annual percent yield. You see that when you take out a loan or something, gives you one rate and then it gives you the effective annual rate yield or the annual percentage yield. It's a simple interest rate that gives the same amount of interest as the compound rate over a certain period of time. So determine the annual percentage yield. So they want to know what it would be if it was compounded quarterly. What would be the regular yearly interest rate? So effective annual yield, $1 invested for 1 year. So that's the the way they test it. So we're going to use the same formula. My formula was um, equals P1 plus R over N raised to the NT. So this is going to be, I'm going to invest $1. 1 plus the rate is going to be 0.02 for A. Compounded quarterly, that's going to happen 4 times. And this is just going to be a 4 because the T is 1. 1 year, $1. So in my calculator, I would do 1 plus 0.02 divided by 4. Okay, and then raise that to the 4. So my answer is 1.02. So to get the what, and it went 0.02 after that. So to get what the annual would be, you have to take this 1 off. So you have to subtract 1, which would give you the 0.0202. Then multiply it by 100. So move it over here. So the annual interest rate compounded quarterly equivalent to 1 year would be 2.02. So you're going to get a number that's bigger than 1. You're going to subtract 1 from it and then move it over 2. Okay, so let's do the second one. So now it's going to be 3% compounded monthly. So it's still 1. This is 1 plus 0.03. Monthly is going to be 12. So up here is going to be 12. So my calculator, I'm going to do 1 plus 0.03 divided by 12. And then I raise that. I always get that answer first because I don't use parentheses, to the 12. So my answer there was 1.0304. So again, I subtract 1. I get 0.0304. Move it over 2 places. So that would be equivalent to 3.04. So both of these are pretty close, compounded quarterly or monthly, to what the annual percentage yield would be. Okay, so now this is another formula. This is the present value formula. So the only difference here is we're trying to find P, or the present value, to invest. Okay, so it's kind of like they took the other formula and they solved it for P. A is the amount accumulated, that's how much we want. R and N all stay the same. So, for example, Will would like his daughter to attend college in 6 years. So that's important, 6 years. When she finishes high school, Will would like to invest enough money in a certificate that now to pay for his daughter's expenses. Will estimates that he will need $30,000 in 6 years. How much should he invest now that with this rate compounded quarterly? Okay, so we want to solve that question to see how much what should be his principal, in other words, is what we're trying to do. So this is how much money he wants to have. This is the rate turned into a decimal. This is 6 years. That should be a 4. This is a misprint. That should be a 4 because I did the question. That should be a 4 because that's N. Clearly that's a 4. And then this was 6 times 4. Okay? Because this should be the time and that should be compound. This is always the compound. And they made a mistake on their slide there. So to put in the calculator, get what you get in the parentheses first, raise it to the 24th and divide. So what it's saying is he needs $25,833 so that in 6 years he would have $30,000 to invest in that CD. So I'm going to do another one for you. So Adam wishes to have $20,000 available in 18 years to purchase a new car for his son as a gift for high school graduation. How much should he invest in a CD with this interest rate? Okay, so it's going to look like this. He wants to have $20,000. And then and this is 1 plus, you change the interest rate, so it would be 0.0155, compounded quarterly, so that's your 4. This is going to be a 4 again. Those two numbers always match, and he wants to do it in 18 years. Okay, so this is how I would do it. 1 plus 0.0155 divided by 4 to the, now I'm going to use parentheses because I don't know 4 times 18 in my head. Whoops. Never mind. 4, there we go, 4 times 18. So that's my bottom number. So I got 20,000 over 1.321094857. So then I just divide. So in my calculator, all I have to do is do this, 20,000 divided by, and it'll throw in that answer for me so that I don't have to retype it. And that's my answer. So he needs to have on hand to get that amount of money, $15,138.96. Okay, so those are the two types of questions that you need to be able to do for this section.